When a complex AI system fails, it can feel like some kind of shocking, out-of-the-blue event. But what if it wasn't? What if it was actually predictable? In this explainer, we're going to dive into the common failure patterns that show up again and again, and more importantly, how you can spot them before they turn into a real crisis.
Now, here's the thing that's so fascinating about this. The core idea is that these failures aren't some mysterious black box glitch. Nope, they are known issues, things we've seen before, repeating themselves over and over, across different companies, even across whole industries. So the key here isn't to be afraid of the AI itself, but to understand the patterns in our own system designs that let these failures happen.
Okay, so to get our bearings, we need a map, and this is going to be our map. It's a simplified look at an IT and operational technology, or OT, control plane. We're going to use this diagram for our whole discussion to pinpoint exactly where these predictable failures are hiding, often right out in the open.
Let's kick things off with our first two patterns. They're all about a really fundamental question. Who or what is actually in charge? And what happens when the emergency brakes just aren't there?
First up, we've got unacknowledged authority. This is what happens when a new system gets rolled out as, just an assistant or a recommendation engine. But then, over time, people start treating its output as gospel. The system basically gets a promotion to decision maker, but nobody ever formally signed off on it. And what you get is this dangerous vacuum where nobody actually owns the risk.
So where does all that unowned risk pile up on our map? Right here, at the approval gates. This is where a human is supposed to be the check, the oversight. But if they're just rubber stamping what the AI says, this critical control point becomes a massive vulnerability. The authority is shifted, right? But the process, the paperwork, it's all lagging way behind.
The second pattern is just as scary: missing controls. And this one, well, this is the classic "we assumed" failure. Teams just assume that, of course, there's a big red button to stop the system in an emergency. Of course, there's a way to roll back a bad decision. But when you ask to see the actual plan, or maybe the results from the last time they tested it, you just get crickets, silence.
And believe me, the consequences here are serious. If we look at our map, a stop signal is supposed to halt the system, period. But if those controls are just an idea someone had, the signal does absolutely nothing. That emergency rollback authority box, it's just a box on a diagram. No one actually has the power to use it. The system becomes a runaway train with no brakes.
All right, let's move on to our next couple of patterns, and you'll see how these things start to connect. These two focus on the data, or lack thereof, and the flawed way we often try to use people as a safety net.
Okay, pattern number 3, insufficient evidence. Just imagine something goes wrong. You go to investigate, and you can see the system's final decision, but you have no clue what data it looked at or what the context was to make that decision. You can't figure out why it did what it did. Without that audit trail, you can't learn from your mistakes, and good luck trying to prove anything to a regulator.
And on our map, you can see this failure lives right down here in what we're calling the evidence and audit plane. If your audit logs and your validation records are full of holes, this whole foundation of trust and accountability just falls apart. When things go sideways, you've got nothing. No way to prove what actually happened. You're flying blind.
And that brings us right to pattern 4, over-reliance on humans. We hear the phrase human in the loop all the time, and it sounds great, right? Like a silver bullet for safety. But a lot of the time, it's just a band-aid for poor system design. Think about it. If an operator clicks approve on the AI suggestion 999 times and it's always right, what do you think is going to happen on that 1000th time when it's just a tiny bit wrong? Their judgment has eroded. It's become muscle memory.
Look, the crucial thing to get here is that the risk doesn't just vanish. It just quietly gets transferred to the person sitting at this human-in-the-loop console. We put an operator in a totally impossible position. We're making them responsible for catching a rare failure in a super complex system, but without giving them the right tools or time or context to do their job effectively. We're basically setting them up to fail.
Okay, on to our final 2 patterns. These deal with the fact that these systems are never static. They are constantly changing, and they have to connect with the real world. And that's where things can get, well, really messy.
Pattern 5 is all about ignoring drift and change. An AI model isn't like a fixed piece of software. The data it was trained on goes stale, the world it operates in changes, and its performance can slowly and silently get worse over time. Thinking you can just set it and forget it? That's a recipe for disaster.
So what's our defense against this? Looking at our map, it's this.
a really solid change control process. This is the gatekeeper. It's supposed to scrutinize every single model update, every shift in data. Without it, you're pretty much running uncontrolled experiments on your live system. Not a good idea.
And finally, our sixth pattern, poor boundary definition. Now, in these regulated industries, there is supposed to be a big, strong wall between the corporate IT world, email and analytics, and the operational OT world where physical things happen. When that line gets blurry, a single, simple failure can have a catastrophic blast radius. And just look at what this means on the map. A failure in some analytics service over here in the IT systems should never be able to directly mess with manufacturing over in the OT systems. But if that boundary is weak, a bug in the IT world can hop right over and shut down a production line. That is a huge and completely unnecessary expansion of risk.
Okay, so we've just walked through 6 of these really common patterns, which brings us to the big question, right? The most important one. After seeing all this, are these really technology failures?
And the answer, pretty unequivocally, is no. The AI is just a tool. It's doing what it was told. The real problems here are failures of governance, of process, and of basic system design. These are failures in how we build and manage systems. They're human failures.
And when we look at our map one last time, with all those danger spots lit up, you can see it so clearly. These aren't just a bunch of random, isolated bugs. They're symptoms of a bigger problem, an incomplete design, where the tough questions about authority and controls and evidence and boundaries, they just were never fully answered.
So, what does this all mean for you? What can you actually do? 3 things. First, just assume these patterns will show up in your project. Go in expecting them. Second, actively use your design reviews to hunt for them. Ask these hard questions. And third, remember this is why governance exists. It's not about bureaucracy, it's about forcing us to have these difficult conversations early before they become front-page news. And I want to be crystal clear about something. The whole point of this explainer is to give you a checklist of risks, a map of things to look out for. It is absolutely not about pointing fingers or assigning blame for things that happened in the past, and it definitely does not authorize or approve any system for use. This is a tool to help you look forward, not a weapon to blame people for what's already happened.
So, I'll just leave you with this one final thought. Right now, today, in the systems you're building or the ones you're operating, some of these patterns are probably there, lurking. The only question left is which one of these predictable failures are you going to find first?